Right, what is ISO? So the first argument about ISO is how do you pronounce it? And I've actually had this discussion with instructors. Uh, some people say ISO and some people say ISO. Uh, there's the reason there's two different ways to say this word is because there's two different stories about how it came to be. The one group believes that it was part of the International Standards Organization, ISO, and others believe that it comes from the Greek word isos, so it's ISO, right? Anyway, that's just, if you want to have a bar fight, there's a way to start one amongst cinematographers. What is it? So here's the thing, and this is where the arguments begin and end and whatever. When ISO was applied to film back in the day, it was a measurement of the film's sensitivity to light. How much image do you get with how many photons that hit that film, right? The same, in fact, in film, it was ASA in some parts of the world, in North America, and ISO or ISO in Europe. Um, when it comes to video, we have a similar thing happening. But ISO isn't really the sensitivity, and this is where the semantics and the arguments can start as well. What ISO is how many electrons will come off a photo site based on how many photons hit it. In other words, what's the ratio of electrons produced by photons? Because it's not perfect. We know that already in the world. If 10 photons hit a sensor, you might only get 8 electrons created, just because of the mechanical loss of the photons hitting the electrons, because of the imperfect materials, blah, blah, blah. Now we're talking physics, right? But if you imagine that 10 photons were to hit and get 10 electrons, you'd have a perfect one-to-one conversion, and you'd have almost no need for ISO because everything would always be perfect. But because it isn't, we have a way to measure how many electrons come off per photon, or how many photons create how many electrons, that ratio, right? So it's not the sensitivity of the sensor per se, but it looks and acts like it is. And it's important to understand that because you can change the ISO, you can change the ratio of electrons to photons artificially, but that, as was mentioned, introduces noise, right? So let's get to it. Why do we have different settings? Because we have to be able to adjust the ratio of electrons to photons. We just have to, right? But you know that there's going to have a cost and quality. The higher the ISO goes, the more noise you're going to have. And why do you have noise at all? Because when you add electrons beyond the ratio that was initially created, some of those electrons are random. They're not necessarily related to the actual photons that hit the sensor. So you get these random electrons that float around, and that's what noise is. Noise is a random signal that gets in the way of your actual signal, whether it's audio or video. So let's have an example of that. Now, this might be really hard to see on Zoom. I don't know how well you guys are reading this. I'm even having a hard time on my computer sometimes. But what this is here is we have 5 different ISO settings: ISO 100, ISO 200, 400, 800, 1600. And as you can see, as you crank up the ISO, we see more light. Well, we're not seeing more light. Remember that the same number of photons are hitting the sensor in ISO 100 as they are in 1600. What's different is the camera is being told to produce more electrons as we increase the ISO. Okay, so it looks like the image is getting brighter, but in fact, the same amount of light is hitting that. And why that's important is because up until the sensor, the lens, all that stuff that's between the camera and the image is affecting the number of photons that hit the sensor, right? We're not increasing the number of photons. We can't. We can only increase how the camera reacts to those photons. Okay, so here's an example of native versus pushed. So in this case, we have a sensor that's at a native ISO of 100 on the left. Clean image, no noise, right? We then take that same image and we crank up the ISO to 3200 and look at all that random noise. All that black fuzz over here on the right-hand side is random electrons bouncing around on the sensor, in the camera, everywhere else, and randomly landing in the data stream, and you get this noisy result, right? So that's the takeaway here. Increasing ISO increases noise. So it's a trade-off. And some of you already know this, right? But it's a trade-off. So if you need more light, you might need a faster camera, faster lens, I mean. a lens with a bigger aperture, right? That's what a faster lens is. Less glass or more efficient glass that blocks less light, right? It's counterintuitive to think that a lens can block light, but they do. Light gets absorbed as it travels through glass or gets reflected around inside the lens, right? So the more you can do to reduce that, and that's why lenses for cinema are so big and so expensive, because one of the things they have is they have the most amount of light passing through as possible. Price, speed, quality, right? You pay more money to get that quality. So common settings, you guys, again, might know this. ISO 100, bright sunlight, bright overcast, studio lights. In other words, lots of photons coming in. You don't need to do much pushing of the ISO. And then we crank it up 200, 400. So sunlight, overcast, outdoor, very overcast. 1600 night shots, 3200 night shots with motion, etc. Right? These are just suggestions. You can push the ISO to get rid of that motion blur. So again, we talked before about the rolling shutter. You can push the shutter speed down to get rid of the global shutter, and you can push the ISO up a little bit to try and get rid of the motion blur. But it's something there's no formula for that. You're going to have to experiment and see what looks best, because pushing the ISO too much might bring back that rolling shutter artifact, right? So, but you can use pushing the ISO up. When I say pushing, I mean increasing it beyond the base to get rid of motion blur. I would not be cavalier with ISO settings. You know what I mean? Don't just start cranking them up, because you're losing quality every time you crank them up. Always try to light your subject properly. That's why television studios and film studios are full of lights. The lower the ISO you can keep, the more photons you can activate basically in the room by having more light sources, the better, right? ISO is a great way to solve it quickly, but you're going to pay with quality once again. Okay, and I just said ISO is sensitivity for film, but for sensors, of course, it just looks like it's sensitivity. And people will argue with you and me, because I've had that argument amongst my colleagues, that because it appears to be the sensitivity, it effectively is the sensitivity. And all I'm trying to say to you is that yes, it appears to act like the sensitivity of the sensor, but in fact, that sensitivity is fixed by the sensor's construction. You're only going to get so many electrons that get bounced off that sensor when the photon hits it, no matter what you do with ISO. ISO happens after that, right? So the sensor produces electrons before ISO comes into effect. The base ISO of the sensor, you could say, is passing it through without any adjustment. So you could argue that the base ISO is the sensitivity of the sensor. But anyway, arguments will start and end there. I like to think of it as two things, because the sensitivity, because ISO is adjustable, right? You can't adjust the sensitivity of the sensor. All you can do is add electricity after the fact. This is like gain in audio. You can't increase the microphone sensitivity, but you can add gain later, but you're going to pay for that with noise. Okay. Is it part of exposure? It's part of the exposure triangle. You guys are familiar with the exposure triangle? Yes, no? I hear crickets. The exposure triangle is the three light altering factors of a camera: ISO, aperture, and shutter speed. Adjusting those three in various ways adjusts the exposure that you're going to get. But ISO isn't strictly exposure, because you're not adjusting the amount of light, okay? Only shutter speed and aperture actually adjust the amount of light. ISO is happening after the light hits the sensor, okay? It's an electrical thing, not an exposure thing. It's part of the exposure triangle, yes, but it's not actually exposure, and that's what I'm trying to say to you. Okay. So common myths: is ISO just raising the luma, like changing the brightness when you're in editing? No, ISO is better than that. It's better to do increase your ISO than if you know you're going to have more brightness. You're better to do it at the camera, because you can make other adjustments while you're shooting than simply adding it in editing later on. Brightening and editing don't depend on that. You can do it. You can adjust your curves. You can adjust your contrast. You can do all kinds of things in post, but don't depend on that. Always best to see it in the camera if you can do it that way. Now, a quick sidebar about what's called dual native ISO, and what that is some of these newer cameras or newer sensors now have essentially two base ISOs, whereas before cameras would have one, like let's say 100, Now you can design a sensor with two, and I think I'll show you the video, maybe, maybe, maybe. Yeah, yeah, because you know what? I'm going to leave these images as a reference because it's harder to explain this. Let me just go to the video, stop share, the video, ISO, ISO, ISO. Oh no, you know what? Yeah, this video, oh, never mind, never mind. So here, maybe actually this guy's video. I'm going to use his video, even though it's not what he's talking about. Hang on a second. Okay, so you remember, hang on, I'm going to stop this, go here. You remember this video I showed earlier. I'm going to use it for a different purpose here than he intended. So we're looking at this video here. We're seeing basically a cutaway view of the CMOS sensor, right? And this is a traditional kind of CMOS sensor where they've put, both of these are actually sort of semi-traditional. What reason I want to stop it here is because this is actually a good thing. You've got what's called a wiring layer, which is the circuitry, the sensitivity portion of the sensor, the pickup point, if you will, where the photons are captured. So what a dual ISO sensor has is it has a second layer. It has two of these wiring layers, right, that allow you to have a second attempt to capture pixels on the same, or pardon me, I'll try that again. You have a second attempt to capture photons on the same pixel. That's called dual native ISO, because now you can actually increase the quote unquote sensitivity of that sensor without adding any noise. What you're doing instead is you're capturing more photons, right? The mechanism for that isn't really that important. That's what my slides explain. And I realize that with time running out, we're getting a bit long in the tooth to explain how. But what I'll do is, we'll stop the share. I'll just do a quick go through what the slides and explain it as best I can. All right. So there's that word again. What dual native ISO does is it releases more electrons for the number of photons that hit it without adding electrons from an external source. And that's the key difference. So remember I said you can push the ISO of a camera and add electrons later on. Those electrons come from the camera's battery and they're just thrown into the circuit at a similar ratio to the photons you captured. What dual native does is it actually, at the point of sensor, it actually triggers more electrons to react and therefore gives you essentially two sensitivity settings, and they're in the menus of most cameras this way, without adding more noise. This is the bottom line for this whole thing. You get more ISO, you have a higher ISO, but you have less noise than you would if you simply cranked up the ISO setting on the camera, right? So what it really does is it expands the range. If the camera goes from say 100 ISO to, well, I don't know, 3200 ISO, you can now have a camera that goes from 100 at the native base, the first native layer, what's called native ISO. And then the second one, the second native ISO could be 800. And then the maximum could now be, I don't know, 6400, right? I'm just picking numbers up out of the air. But you have two benefits. You have a much wider range, and now you have a setting at 800 ISO, which is the native setting, which means you have a high ISO with low noise, right? So very desirable, is my point here. This technology has been out for a couple of years, and it's quite a desirable thing. And then these illustrations kind of show a couple of other things we want to talk about, and that is conventional CMOS versus backlit. So remember in the last lesson, I mentioned that the CMOS has all the processing on the top, and the photo layer is actually covered by some of that processing. So now what we have is something called a backlit CMOS. So again, this is a desirable feature. And what they've done is they've moved, by putting transparent materials, they've moved the wiring behind the CMOS sensor, right? So now you've got the advantages of a CCD in that you've got a full photodiode, which means it's going to be more sensitive, brighter, right, than a standard conventional CMOS chip. And this is called a backlit CMOS. And this is, again, becoming fairly common in the industry. but not universal. So I would, when you're looking at cameras, consider this feature as something you might want to have a look at. And I think that slide's out of order. There's the dual. Yeah, so this is just a recap so you understand what I'm saying. This is the conventional CMOS with that photodiode in one corner. The backlit CMOS has the entire surface photodiode, and all that stuff, all this stuff here that is the processing plant, if you will, is underneath. It's hidden below, right? Remember, the CCD doesn't have any of this. It's all on another chip. CMOS still has it on the same chip, but they've put it underneath, right? It's a little noisier, but they're getting rid of that as well. They're working with that and processing and making it a better deal. All right. That it? Yeah, and this just illustrates, again, the old way of CMOS pixel sense section, circuit section, and the new way circuit section underneath, pixel section is now bigger, right? And that's that. So that's the end of that.